Have you ever wondered how your search engine seems to read your mind? You type a few words and it just gets what you mean. We speak in context and nuance, but computers run on pure logic. So how do they understand us? By the end of this, you'll know exactly what technology bridges that gap. It all starts with this fundamental problem, the language gap between humans and machines. Right. When you search for something like best Italian place near me, you're not just asking for web pages with those exact words. You're expressing an intent. You're hungry, you want good food, and you want it close by. The technology that figures all that out is natural language processing. I think the best way to understand this is to imagine we're building a digital translator, but not for Spanish to English. This one translates human to computer. That translator, that's natural language processing, or NLP. Here's the core conflict it has to solve. Our language is messy. It's ambiguous. If I say the pitcher is hot, am I talking about a baseball player having a great game or a jug of water that's been in the sun? It all depends on context. Computers, on the other hand, don't do context. They are literal. They need precise instructions. They can't just guess. And that's where NLP comes in. It's the engineering solution. It's a field of AI focused entirely on giving computers the ability to understand, interpret, and even generate human language. It's the software that lets our two very different worlds communicate. So when you boil it all down, the goal of any NLP system is to take the unstructured, chaotic data of human language and transform it into structured data that a machine can actually analyze and compute on. Okay, so that covers the why. We know the problem NLP exists to solve. Now let's look at the how. We're going to pop the hood on this digital translator and see how it works. To process language, a machine has to deconstruct it, kind of like a detective analyzing a crime scene. It starts with syntax, the basic grammar rules. Then it moves to semantics, the literal meaning of the words. It also has to consider pragmatics, the hidden context, like figuring out sarcasm. And finally, there's discourse, which is tracking how meaning flows across multiple sentences. This usually happens in a pipeline, like an assembly line. First up is text pre-processing, which is just cleaning up the raw text. Next is feature extraction. This is the critical part where clean text gets converted into numbers. With numbers, we can move to model training, where an algorithm learns patterns. And finally, that model can be used for analysis and prediction on new text it's never seen before. Let's just zoom in on that first step. A key technique here is called tokenization. It sounds complex, but all it means is breaking down a sentence into its smallest useful parts, or tokens. So a sentence like, "the cat sat on the mat," simply becomes a list of individual words. This makes a long sentence much more manageable for an algorithm. So now we have our tokens. A computer can't do math on the word cat, so we have to convert it into numbers. That's feature extraction. Each token is mapped to a list of numbers, a vector. You can think of this vector as a coordinate in a vast map of meaning. This step is where abstract language officially becomes concrete mathematics. Now, the way we've done this has evolved a lot. Early NLP was all rules-based. Engineers literally wrote grammar rules by hand. Later, we shifted to statistical NLP, which used probabilities to guess meaning from lots of text. Today, we're in the era of deep learning, where huge neural networks learn all these patterns automatically, allowing for a much deeper understanding. All right, this is not just theory. NLP is running quietly in the background of many of the tools you use every single day. Every time you use a search engine, you're using NLP. When you talk to Siri or Alexa, that's NLP. Real-time translation services, the spam filter in your email, these are all powered by core NLP techniques. And for practitioners, this is where it gets really powerful. NLP is transforming entire industries. In healthcare, it analyzes unstructured doctor's notes. In finance, it gauges market sentiment by reading the news. In customer service, it powers the chatbots that offer instant support. And of course, this brings us to the most visible application today, the incredible conversational skill of large language models like ChatGPT. It's all built on top of this NLP foundation. They are a massive, scaled-up application of these very principles. So, if you're going to remember just one thing from all of this, let it be this next idea. At its heart, natural language processing is the bridge. It's the technology that closes that communication gap, allowing us and computers to finally work together. And your key takeaway is this: NLP isn't just about computers understanding words, it's about them understanding intent. And that's the difference between a simple script and true machine intelligence.